They're hoping to provoke favorable special cause variation showing up with shorter triage to ECG time intervals. In part 2 of this series on run charts, we introduced run chart rules and how they're used to point out statistical signals that show that something unusual is taking place in the process you're watching. To be a bit more technical, these statistical signals are strong indicators of non-random process activity. Also in part 2 of this series on run charts, I presented one of the run chart rules, the one for identifying a trend. When the variations we see are just random, that's a pretty good sign that the process is operating in a very consistent manner. Now, it may be consistently showing wide variability in performance, it may be consistently good, it may be consistently bad, or it may be consistently somewhere in between. The point is that in the absence of statistical signals pointing out non-random behavior, the process is very likely to be performing consistently at whatever level of performance it happens to have settled itself into. The random variation we see in that consistently performing process is sometimes called common cause variation, and it's just the common everyday stuff or noise going on in the background that produces that sort of variation. In contrast, when the variation of the process is non-random, those statistical signals will start to show up in your run chart. That non-random variation is often referred to as special cause variation. Something different seems to be going on. It's a flag for someone to take a closer look to see what's happening. If that something going on is bad, you'll want to find out right away and stop it, prevent it from happening again. But if it's good, you'll want to understand why and maybe share it and try to make it happen more often, or use it to help establish a better performing new normal. So here in part 3 of our series on run chart, here's the next run chart rule, the shift. A shift has occurred when you have 6 or more data points in a row that all land above the center line, or there are 6 or more in a row that all fall below the center line. When a process has just common everyday variation going on, it's very unlikely, statistically speaking, that 6 or more data points in a row will all land above that center line or all of them fall below it. So let's consider an example. A local emergency department started a rapid cycle improvement project to reduce their arrival at triage to 12-lead ECG time on STEMI patients that presented as walk-ins. Looking at the data from their STEMI registry records, they have been averaging 14 minutes 21 seconds, or 14.4 decimal minutes. And decimal minutes is the way that programs like Excel will often show fractions of a minute. The ED staff leadership thought they could do better, so they formed an ad hoc QI project team to take this on. The cardiovascular nurse coordinator, having some strong QI training, knew that once a quarter data points were not going to be frequent enough for their rapid cycle improvement process. They wanted to make an impact in the next couple of weeks, so they decided to use the data they entered into their STEMI registry to plot their triage to ECG times for every eligible case that comes in. So each case would be plotted as a new data point on their run chart in chronological order. And they have roughly 100 chest pain cases a week come into their ED as walk-ins, so they use the last 100 consecutive cases to establish a baseline. And a baseline is used to define how the process is operating now, so that any changes that come in the future can be compared to that baseline to see if the performance of the process has changed. And an average or median is calculated for the performance during the baseline period, and that becomes the value of the center line that's plotted on the run chart, as I described in part 1 in this series on run charts. Here's what the baseline run chart data looks like. It is important to note that they were not making any other changes to their process during the time the data for these last 100 consecutive cases were being collected. They applied the complete set of run chart rules and did not see any evidence of special cause variation in those 100 cases used for the baseline. The average arrival at triage to 12-lead ECG time for these baseline cases was 14.4 minutes, and that is the value you see for the centerline. Now, the team looked at the peer-reviewed scientific literature, thought back on some of the presentations they have seen at conferences, articles in trade journals, that sort of thing, to identify some best practices on this process that they thought they could apply to their ED. When they took what they thought were the most promising ideas that could be applied to their setting, they adjusted those benchmark processes to fit their circumstances specifically, and then implemented those changes. Now remember, the baseline cases were the first 100 cases. The QI project team, by introducing changes to their process for how and when a 12-lead ECG is acquired at the ED triage desk, is intentionally trying to create non-random behavior. They're hoping that the status quo from the baseline results is disrupted. They're hoping to provoke favorable special cause variation showing up with shorter triage to ECG time intervals. And we want to know about a change in process behavior as soon as possible after it starts to happen. We watch as each new case is added to our run chart, as we anxiously hope to see those statistical signals tell us when a significant process change has started to take place. If our process change is not effective, we will not see the favorable special cause variation show up. Remember, monitoring a run chart is like watching a movie. Each data point is like a new frame in that movie. So let's take a look at the run chart movie. It will start out with the baseline data in view, and we'll start adding new data points. Now, I've obviously already added all the data to the chart, but for the purposes of this example, imagine that we are accelerating time and watching new points come into view as cases are entered into the STEMI registry. The data will scroll along to the left so that the newest data shows up on the right side of the graph. We start out seeing data points 81 through 100 on the screen. These are the last 20 data points from the baseline period. As the data is added to the chart will move to keep the most recent 20 or so data points in view. This is called a moving data frame. The new process is implemented, and the results from the new process will start with case number 101. In this simulation, the data is being added pretty quickly, but soon we can see that fewer and fewer data points are showing up above the centerline. This is the shift that we have been talking about. The ED arrival to first ECG times are getting shorter, and as a result, the position of the data on the graph is shifting downwards. It's pretty easy to see this well after the change has taken place, but since we want to know as soon as possible so that we can lock in the process change, or if the shift is bad, we can terminate the process change and try something else. The run chart rule for detecting a statistically significant shift gives us that early indication. So let's watch the data flow again and apply the run chart rule for detecting a shift as the new data is added along the way. Remember, we're looking to see if we see 6 or more data points in a row show up over the center line or all under the center line. We start out seeing data points 81 through 100 from the baseline period, and we'll watch for instances where several data points in a row are above or below the center line. Here we see several. 1, 2, 3, 4, 5. Not enough. Moving on. Here's another grouping below the center line. 1, 2, 3, 4, 5, 6, 7. So it's case number 162, where the first set of 6 or more consecutive data points below the center line first appears. This is more objective and reliable than just eyeballing on all but the most obvious scenarios. But even with just our eyes, we can see that the shift goes even lower over time, representing shorter time intervals. I'm going to show you the same data again, but in a different way that I think is more powerful. Instead of adjusting the view of the run chart to show the same amount of data each time as new data points are added, which is sometimes called a rolling or moving data frame, we're going to make a longer graph with space already added to hold the new data in the same view. The advantage is that your eye does not have to readjust to the new view and take in new data at the same time. You can focus on just the new data. And I think it helps you see how the new data compares to the older data much better. Let's take a look. This first section of data shown here has the first 100 cases in the baseline period. The variation you're seeing in that baseline period is common cause variation in the process, just the normal everyday stuff or noise going on in the background. Data will start to be displayed in just a moment that came in after the improvement intervention began. Here we go. The point where the shift criteria is first met is right now. Not all that obvious to the eye alone at this early stage. As more of the data scrolls into view, you begin to see visually how the shift downwards takes place. You can see how the performance settles into a new normal range. This compressed view makes this type of visualization possible with larger sets of data points. This variation shown as the downward shift is one of the special cause variations that provides a statistical signal that the process is performing differently. In this case, it is performing better, which is what we were hoping for when we made the change in the process for how and when 12-lead ECGs were captured on ED walking cases presenting with chest pain. So there you have it, the run chart rule for shifts and perhaps a better appreciation for some options in how your run chart is formatted. In the next post, we'll take a look at some more of the run chart rules. On the ImproveTheSystem.com website page where this vlog is embedded, scroll down to see some notes and links to other resources that expand on the topic just presented. A complete transcript of what's presented is also provided on that page. If you have any questions or comments, please contact me directly at mick@ImproveTheSystem.com. Feel free to reach out and I will do my best to reply to every inquiry. Thanks for watching.